in this video, we'll write the code to existing tests. So we'll just do TDD style coding for a very simple problem. And let's take a look at the domain. So there is RNA transcription domain, and basically for given DNA strand, we are supposed to return its RNA complement. And if you take a look, there are strands listed below and transcribed RNA. I'm not gonna go through that. It's available on the GitHub in the link below. So just take a look. And that there are already prepared tests for us. So if we take a look at tests, they are coming from the business based on the requirements and on the empirical knowledge of how DNA and how DNA corresponds to RNA. So let's take a look. So for empty RNA sequence, there is an empty string, and this is basically those are basically those pairs presented. So for cytosine, for guanine, we get cytosine and so on. And let's take a look at our code. So there is no implementation, and this is our job to do it. So I'll move this window right here, and let's take a look at our tests. So the first test says that empty RNA sequence returns an empty string. Okay. So basically, to go with TDD style, we could just write this returning the empty string, and the test is succeeding. Okay, let's try to continue. So the next test says that if cytosine is an argument, then we should get the guanine. Okay, so let's say if nucleoid equals C, then return G. Okay, check this out. Okay, nice. Let's keep going. So this test is gonna fail, obviously. So now we need to fix it. So if there is nucleoid equals G, then we return C. Okay, let's take a look. Okay, simple enough. Let's keep going. And next test is obviously once again going to fail. And then given we get thymine, we are supposed to return adenine. Okay, we need to test this. There is no place for mistakes. Let's check another one. If there is adenine, we should get uracil. Obviously, it's failing. Let's fix this one. So if there is adenine, we should get uracil. Okay. Okay. And there is next one, the last test. There is a sequence. So if there is if the nucleoid is equal to such sequence, it's other way around. So if the nucleoid is equal to, well, I'm not gonna read it, but this RNA complement, then we should return it. Okay, simple enough, but it doesn't scale because if we change this fact to theory and we add some inline data, and we actually say that there is DNA and RNA as input parameters, then we could use it like this. Obviously, this example is still going to work. So if we do it like this and use DNA, okay, let's check the tests. Everything is fine. However, if we change, let's say here to see, I'm not sure if this is proper in terms of DNA and RNA, but let's assume it is. The test will fail. Okay. Well, because we don't cover this scenario. So what we need to do? Well, definitely we need to change this implementation because it doesn't scale at all. So let's let's say that this interface of RNA transcription is not, we cannot modify that because someone expected to use it in such way. So what we can do, we can actually create our new namespace. and let's call it, I don't know, maybe we can call it a domain. And we should create a class. So we need a class that will do DNA to RNA transcription. Okay. And what we actually have here. Given, let's create a method. It expects string as a return type, and let's call it I don't know, transcript. Or okay, let's go out to transcript. Will be good. And we need a string nucleotide. Nucleotide. Okay. So instead of having this if statements right here, let's use our new class. So I'll just move this implementation right here, and instead we'll create our class. So DNA to RNA. Let's instantiate it. Okay. And now let's do return DNA to RNA transcript, and nucleotide is a parameter. Let's see. Well, it didn't fix anything. The test has failed because our implementation obviously is not really good. So let's fix it. Let's start with creating a dictionary. We'll just create a dictionary which will take two char variables. And let's call it DNA to RNA, and let's just create it. And now let's, in this dictionary, as this is a limited sequence that hasn't started and end because there is only 4 of them, let's just keep it as dictionary right now. So we can say that for C there is a G. Okay, so just key value. For G there is C. For T there is an A, and for A there is an U. Okay. So we have our dictionary, and instead of returning this, we can actually say that we can return DNA to RNA and at nucleotide, but we actually have to parse that, and okay, we can parse that because cannot convert. And we'll just for now. Okay, let's see. Oh, we broke 2 tests. Okay, so let's fix the first one. So let's say if nucleotide any, if there is no characters in this string, then we'll just return it. And this should take care of one of the tests. Okay, and there's this problematic sequence. So let's take care of that. So obviously we need to use our dictionary in different way because this way is not going to help us to actually get the full sequence. So let's try to use it. We could use the for each loop, and we can actually say, okay, so let's use for every char in nucleotide, sorry, and now we're gonna take care of our chars. But before that, we will create a place where we can actually store our result, and let's use string builder for that. Empty string builder, and let's take a look. What we want to do is that we want to append to our result corresponding RNA for given DNA, and then we actually want to return that result. Okay, and let's remove this, and we want to actually remove result to string, return result to string. Let's see, and our little tests are passing right now. But what would happen if we would just bring some strange sequence here? Let's take a look. Oh well, there's an ugly error. And then now we would have to decide what to do with that. Actually, that would be a question to a domain expert. But if we don't want to take care of that, if we don't want to see this ugly error, let's say that we can filter the input, so the nucleotide, and we can actually check that the key, so given DNA, is contained in the dictionary. Okay, so only take those that are contained in the dictionary, and let's take a look. It still fails, but that's because the empty string is returned. And that's basically it. So we finished writing the code to existing tests. So right now, what I would do, I would try to dig some more domain knowledge to maybe get some other cases for translating the DNA into RNA. If you liked it, please give me a thumb up. You can subscribe to the channel. I'm planning to do some more videos about the testing. And thanks for watching.